There are 3 sponsors for today's session: HashiCorp, Digital on Us, and of course the star of the show, SAP Ariba. I'm going to spend just a quick minute on some brief backgrounds of those 3 companies, as well as our speakers, and then we'll dig right in here. So HashiCorp, actually, let me take a step back. My name is Josh Radich. I'm a strategic account manager with HashiCorp for a couple of years now. And I'm part of a pretty large team that manages the overall partnership between SAP and its respective lines of business, which SAP Ariba is definitely one of. I manage the operations from the state side, and then I've got counterparts over in Europe that we team up with the lines of business that are really headquartered and ran out of Germany and other parts of Europe. So HashiCorp, founded in 2012 with the goal of revolutionizing data center management, application development, delivery, and maintenance. And today we're really hyper-focused on providing companies with consistent workflows to provision, secure, connect, and run any infrastructure for any application. Today's session is going to focus on the connect and run portions of that solution offering. Digital on Us is our co-sponsor. They are hyper-specialized. They are a hyper-specialized Hashi partner, focusing on cloud-native development, infrastructure as code, including DevOps and DevSecOps, as well as site reliability engineering, to build more reliability to drive digital transformation for our mutual customers. They were named HashiCorp's Strategic SI Partner of the Year last year in 2019, and have created unique accelerators across Terraform, Vault, Consul, with newer models for implementation and support. They have 300 plus engineers supporting large enterprises, as well as some of our strategic startup customers. And then the star of the show is SAP Ariba. Ariba was founded in 1996. They went public in 1999, and they were acquired by SAP in 2012. SAP Ariba is a software company that provides a procurement and supply chain solution that enables companies to move faster and spend better. The SAP Ariba solution enables companies to connect to the largest B2B network on the planet, creating dynamic digital collaboration with millions of suppliers and trading partners all around the world. And then our presenters today. So we've got Ranjith Pillai and Ariel Mendoza. Ranjith is an architect on SAP Ariba's Microservices platform. He has 20 years of industry experience, and he's been foundational in envisioning, setting up, and operationalizing the microservices landscape of SAP Ariba. A little fun fact that we're joking about is that he says if we consider 3 minor merged pulled requests good to be considered or called a committer, he is in fact a committer to the Nomad source repo, and touts that title proudly. Ariel Mendoza will be running the demo portion of today's session. He's a DevOps engineer. He's a senior DevOps engineer with 11 plus years of experience in IT infrastructure with high focus on DevOps philosophy, and he really specializes and is certified in the HashiCorp technologies. He's a former consultant building scalable infrastructure with multiple companies. He's actually had 2 different tenures or stints with SAP proper as well as SAP Ariba. And today he's working for Digital on Us, providing services for SAP Ariba, managing, supporting, and architecting their production platform. So again, appreciate all the time. Please, hope you find it useful and insightful. Please do leverage the Q&A function and ask as many questions as you feel as you'd like, and then we'll take those on at the end of the call. So with that, I'll kick it over to Ranjith to present.
Hey, thank you, Josh, for that great intro. So quick check, can you see my slides?
You are up, yep.
All right. So welcome everyone to the session on SAP Ariba hybrid networking in the HashiCorp landscape. Today, we will cover some details on how SAP Ariba is leveraging the HashiCorp products to satisfy the customer and business needs, taking 2 specific use cases that we solved with the highly configurable and customizable components from HashiCorp. Let's briefly look at what we plan to cover today. To start with, I will take you through an overview of how SAP Ariba's microservices platform uses HashiCorp products, along with a bit more details of the platform itself to give the context for this session. After that, we will cover two specific use cases that we want to get into detail, followed by a demo at the end. Let's get started. In the next 5 minutes, I will make an attempt to give an overview of the lay of the land so that the subsequent use case discussions can be understood clearly. SAP Ariba's microservices platform covers the entire spectrum of microservices journey, right from development all through operations. It includes components and services for each stage of this process. Let's say starting with development environments, CI/CD pipelines, deployment environments, secrets and configuration handling, as well as logging and observability. In each of these stages, SAP Ariba leverages an appropriate HashiCorp product as seen in the technology slide that comes next. This also makes this platform environment agnostic for the applications purely because of the abstraction that the HashiCorp products bring in. This makes it possible for Ariba to run the production workloads in bare metal as well as hyperscalers seamlessly. Let's have a look at the technology slide. For example, if you look at the left extreme, the development environment setup uses Vagrant. Predefined Vagrant boxes are shipped so that developers can get running in no time. In the infrastructure setup, it's completely based on Packer-based images for bare metal as well as hyperscalers, and provisioning is using Terraform, obviously. The runtime environment, as you can see, is based completely on Consul, Nomad, and Vault. We also heavily leverage ENV Consul as well as Consul template. Both are open source products from HashiCorp for abstracting the underlying infrastructure pieces from applications for secrets as well as application configuration. So if I try to summarize, SAP Ariba is a big time HashiCorp shop. Today, Ariba has presence across 8 regions, out of which 6 regions are in bare metal, while 2 of them are in Google Cloud. It is in United States, Europe, KSA, UAE, Russia, China, Japan, and Australia. This platform has been in production for 4 years, hosting approximately 60 plus services in production and having approximately 16 data centers, in each region having 2 data centers. And if you look at the last 90-day statistics, there are around 1,800 production deployments and around 23,000 development deployments. I would like to take a moment in showing how Ariba runs Consul with WAN gossip enabled to allow cross data center discovery. The primary use case for doing this is to allow the entities in the primary data center to replicate data to the DR data center. So this is done for handling the disaster management in case of a regional failure. In addition, all traffic routing, including blue-green activation, is based on the Consul service information, which is leveraged by the cluster level Nginxes that run inside the cluster. As you can see at the receiving end of the traffic, the ingress passes through an FI, which terminates all the external traffic and forwards it to the cluster level Nginx. And this Nginx itself is wired to the Consul data using Consul template as the intermediary. This helps to reconfigure Nginx automatically. So these slides up to here, I hope gave a good background of the situation. Now, let's get on to the first use case, SAP Ariba's internal networking solution. So why are we even looking for a change in our solution in the first place? We have been using an other product as an overlay network in our container networking layer. This is not supported anymore by the vendor. Also, this part of the system has given us plenty of trouble that it was really threatening the stability of the production systems. Also, it was complex to operate and it was really affecting scaling up in terms of the number of services that we need to support. In addition, we wanted to have a clear path to bring in network policy management at L7 as the next step in making an operationally stable network setup for containers. Now, given that we have now decided to change our system, we had to ensure a couple of high-level goals are met, which were, firstly, we wanted the overlay networking changes to be independently rolled out compared to the rest of the infrastructure. Second, a simplified software-defined networking to keep the operations really simple. And third, a migration path to ensure that we can leverage the advanced capabilities of a service mesh. So what was the solution? The solution that we decided was to deploy the overlay network of Flannel as well as the data store for Flannel, which is HCD, using Nomad into the clusters. Again, this was possible due to the flexibility available from Nomad. So think about this. You are running a cluster in the first place, and now you deploy a Nomad job and enable the whole overlay network for the cluster itself, right? So before I get into the specifics of the deployment, let's have a brief look into Flannel itself. Flannel is one of the leanest solutions with minimal operational overhead in running an overlay network. It also gives a path for setting up Consul Connect for L7 network policy management. The network spans across multiple nodes, and the Flannel wires itself to the Docker bridge network and also enabling additional IP table entries for allowing inter-host communication. So Flannel receives a large CIDR block as configuration via HCD. As I said, HCD is its data store, which is then split into chunks of 256 IPs per host. This distribution is completely coordinated using HCD as the backend data store. Let's look at the highlights of the solution. As I said earlier, HCD was deployed using Nomad as a service into the server nodes. So when I say server nodes, these are the nodes where Nomad, Consul, and Vault are running in the server mode. This was possible because Nomad allows non-container workloads to be deployed using raw exec driver. Another aspect of this deployment is that HCD itself needs to discover its peers. So how did we achieve that? Here, Consul came to the rescue. Each HCD node registers with Consul with the alloc index interpolated variable that comes from Nomad, and that's how each of them gets an uniquely addressable name by which all the nodes discover each other. Now, coming to the Flannel part, the capability of Nomad to deploy system jobs enabled us to deploy Flannel in every node in the cluster. Yet again, this also leverages the raw exec capabilities of Nomad. And along with the Flannel task, an additional task we added in the job specification, which reconfigures Docker in each node to wire the Flannel supplied configuration into the Docker bridge network. So that summarizes the first use case that we could implement using the HashiStack. Moving on to the next one, the new customer challenge. Let's talk about this one. So what is this scenario for us? In this one, what we want to cover is how we were able to meet the customer requirements on data encryption in transit. This was also aligned to the internal company goals on security and compliance. This demanded a change to our implementation to handle TLS traffic for all intra-cluster communication. So what were the challenges that we faced in achieving these requirements that led us to this new solution? First of all, given the spread of data centers across regions and environments, the versions of the Nomad and Consul that we were running did not allow to adopt Consul Connect as the solution at this time. At the same time, we were having contractual obligations with the customer requires us to finish this enablement by Q3 2020. In addition, we had some reusable patterns around secret and configuration distribution via Consul template helped us to get this rolled out with very minimal effort. So what is the proposed solution here? This solution here involves multiple moving pieces. First of all, we have Consul that manages the data store for prepared queries, which is again the base for our blue-green deployments and traffic activation. Vault plays the role for certificate and secret management for the TLS communication. Nginx plays the role of sidecar that terminates the TLS traffic. And the in-house Docker images that we have in the platform allowed us to inject the sidecar into the applications, and this was quite handy. So how did the HashiCorp products, Consul and Vault, helped us in this scenario? The very fact that the enterprise versions that we use, we have an official support for it from Hashi. Consul, again, provides us with the distributed but highly available storage backend for all configuration information. Certificate management is seamless with Vault in the picture. And real-time health checks supplied by Consul ensures the resiliency of each of these moving pieces in this platform. So if we make an attempt to compare or a quick comparison of what we have versus a standard Consul Connect based solution. If you see in this comparison, apart from the version compatibility and the no downtime enablement, Consul Connect is clearly the way forward. At the same time, what we did was critical in meeting the customer commitments, and there also it was possible only because of the highly configurable HashiCorp components we were using in our system. So let's look at the mesh architecture that we have. This picture tried to depict a really high-level view. So if you look at this this picture, you can see those different moving pieces that we discussed in the previous slide. You can see there is a sidecar Nginx inside every single container, whether it is a Java container or a Node.js container. You can see the Nginx sidecar there. The sidecar is bootstrapped using the data from Consul and Vault. That information is translated to Nginx understandable configuration using Consul template. So by this, all the communication between entities within the cluster happens over TLS. So that brings an end to the slide part of this presentation. It's demo time now, and Ariel will take us through the details of these use cases that we discussed. Ariel, take it over.
Thanks, Randy, for this magnificent explanation about the topics discussed today. Let me start sharing my screen. Second. Share. Okay, I think everyone can see my screen now. Hi, everyone. My name is Aaron Mendoza, and I'll be conducting the demo of our previously created cluster, which is running a Nomad Consul and Vault cluster set. So as you can see here, we have already a Consul cluster which has a couple of servers, 5 Consul servers actually, and we have another one which is running 5 Nomad servers along with some clients. So here pretty much we're going to go over what Ranjit explained already and see how it is in the technical side. So let's get here to the console. As we can see here, we have no running jobs. So I have prepared already the job definitions for each of the jobs that we're going to deploy, which will be etcd, Flannel, Web Server Nginx, and also will be a sample app, which is a Spring Boot-based application. So let's first get to the deployment. So in this case, we're going to deploy first etcd. As you might know, you can plan.
You move the window a little up because
Sure.
we cannot see the bottom portion of the terminal window.
Okay. As you might know, in order to deploy a Nomad job, you can either plan it beforehand, or you can actually run. The only difference is that you won't get the actual evaluation of the constraints are in the job definition. So here we're running the plan and then executing the job run for etcd. We're going to go through the HCL or job definitions in a moment. So let's get the rest of the services deployed so they can come up by the moment we're getting back to them. So now let's take a quick look to the etcd and Flannel job definition. In Nomad, we have multiple schedulers. You have service, scheduler, system, and batch. But here in etcd, it is deployed as a service. As you can see here in line number 3, it is a service type. As the reason for this to be defined as a service is because this is the optimal scheduler for long-lived services that should never go down. And our Flannel, in this case, is deployed as a system job, so it can run on all the clients and invoke during horizontal scaling. So this is very convenient whenever you have auto-scaling groups in the cloud, or whenever you are simply adding more hosts into your on-prem cluster, because the moment you add a new node, this system's job will be extended to this new host. So another thing that it's worth mentioning is about the kind of driver that we're using here for both. As Ranjit already mentioned before, we're using the raw exec. One of the benefits of this driver is that it lets you run commands for a task without any isolation. So here we're executing as it can be seen on the line 29. We're executing some scripts that are there to manage etcd and Flannel. All these are downloaded from our Artifactory along with the binaries. So these two can later on get registered in Consul to make use of the service discovery feature that it provides. Another thing that I would like to mention about this kind of jobs, just because of their criticality, is that it's very convenient or highly recommended to use the preemption, which is a Nomad feature to displace running jobs with others that have a higher priority. So in that way, you can ensure that these services will be always placed. Now, going back to Consul, here we can see that our services have been already deployed and registered. In Consul, we can see that Flannel, as mentioned before, it's having its tags based on the Nomad allocation index that it's set in the job definition. And the same for Flannel. Here it's deployed on all the nodes of the cluster. Just because it's a system job and it didn't have any constraint, it's going directly on all of them. So now let's get back to the image so we can recall how the architecture, how the overlay network overview was. So for etcd, as mentioned before, here is using one of the Consul service discovery benefits because it can easily discover peers node. And for Flannel, just because all the data store is stored in etcd, it always has to fetch its configuration from a healthy etcd node. So that part is actually taken care of by Consul just because of the health check that it's registered the moment the etcd service is deployed in the cluster. As we can see here in the image, we have two different clusters. Now let's log into each of the, two different servers. Now let's log into each of them so we can see which is the network configuration on each. Let's get, okay, so as we can see here, we're going to log into this application. It's a Spring Boot application, which is deployed onto different nodes. So let's get here. In the meantime, we'll come log into the other one. Okay, we can see that both of the containers are here. So another one of the things taken as a reference, the diagram, is that we have the Flannel. You can see here that it says VTP. That means that it's a VXLAN tunnel endpoint, and we can see the type of this by executing this command. So here we can see that it's a VXLAN type device. It's the one that it's actually enabling the VXLAN group defined on the ID that you create, that you set the moment that this device is being created. And the same is going to be on this other host. Now let's take a look to the IPs. So we can see that they are actually from different subnet mentioned before. So this is the IP of the host, and out of this, Flannel is going to create a completely different subnet, which is the one actually defined the moment you are installing or setting up Flannel. So this is the subnet that later on is split into, or that is used in order to create this overlay network on this host. On this other host, we're going to have a completely different subnet, but it's also part of the same CIDR range. So while taking a look to the containers, we will see that no matter if they are from different subnets, anywhere the traffic will be possible because of the VXLAN. And the same will be for the other host, for the other container. It will be able to talk back to this other guy. So I think for Flannel and etcd, this is pretty much all what I can share. So now let's move to the other topic that we discussed previously. It's regarding the service mesh. So the way we're handling it is pretty much we're enabling the Docker encryption through a environment variable that it's set in the Docker image. So that it's actually letting know the Docker container that it has to pull the information, the certificates from Vault through the console template. So let's get to the main web server Nginx, which is the one that it's actually taking care of most of the service discovery and configuration management for the service mesh infrastructure. Here we have our console template, which is running, and it's actually querying the information or the certificates from console, and it's working over our upstream configuration files, which are pretty much the ones that we have here. And these are the ones that are taking care of defining which are the upstream pods. In this case, this is our Spring Boot application, and we will do a check of the remote TLS certificate that this one has, so we can actually see that it's getting the certificate through console template. So this is the remote service, and we are going to do the actual query. So here, this is the certificate that we're actually injecting in, or that we are getting generated through Vault. So as we can see here, this endpoint is having a TLS version 1.2 certificate, and it's our own signed certificate by our Ariba team. So yeah, in this way, we can see that this remote container is actually having a sidecar. Now let's that it has its own certificate. Now let's get into that other container, so we can see that all the traffic between the sidecar Nginx and the Spring Boot applications, it's also secure. So this is the sidecar certificate, sorry, the sidecar Nginx, and it's having the configuration here in the upstream block for pointing to the remote Spring Boot applications, and all of it is happening through the 443 port, meaning that it's secure. Let's do OpenSSL just to make sure that it's actually using the certificate, and it does. It's using the same protocol. So from end to end, all the communication is encrypted using our CI sign certificate. And as of now, this is all what I got for covering the demo for both of the topics discussed. And from my side, it's pretty much all. Thanks a lot for staying here, and I will hand over this to Josh.
Thanks, Ariel, and thanks, Ranjit. Ali, I'm going to let you drive here. It looks like there's been some good activity in the Q&A that that Ranjit has been staying on top of, but I'll let you drive for any active questions.
Perfect. Thanks, Josh. All right, so we have one question. And just a reminder, you can see the Q&A box at the bottom bar of your webinar. Just type it in there and we'll answer accordingly. So one question here, any plans on moving to Connect? Why or why not?
Ranjit, do you want to talk to that about what what you guys are what your guys' plans is with Connect?
Yes, I just answered that question. So yes, we do plan to move to Consul Connect based on the status of our upgrades of the various data centers that we have. As I mentioned during my talk, that the Consul and the Nomad versions that run in our data centers needs to be upgraded first before we can get to the state of enabling Consul Connect. But yes, that's in our cards.
Wonderful. Let's see if there's no other open questions right now. But Ranjit, you did a really good job responding to people's questions in real time. Do you want to elaborate on any of the questions that you've answered? One question being, why did you choose Nginx sidecar instead of Envoy? Any specific reasons?
Yeah, so as I mentioned there, so definitely one of the reasons why we chose Nginx was really the fact that we had many reusable patterns around Nginx, which we have been leveraging in our production data centers. And it was really battle tested in terms of the traffic patterns that we have been using for running our microservices. And given the short time span to design, implement, roll out, activate to meet the deadlines, we had to stay with the products which we know and which we know that it will be suiting our needs. That was one of the primary reasons to stay with Nginx. And Envoy enablement was essentially we kept as the second phase when we decided to move to Consul Connect either with Envoy or without that. So whichever path we take there.
Wonderful. And we have another question too. What about the logging and observability?
That's a tough word to say. Yeah. So logging and observability does not straight away leverage any HashiCorp products as such. So we use Datadog for all our observability aspects, including StatsD based metrics, APM, NPM, RAM, as well as tracing. While the logs, which is the application logs that are emitted from each of the services that run, goes to Splunk.
We have another question here. Are you handling console intentions?
Hey, Christian, no, we are not.
Okay, we have another detailed question here. During planning for a Connect migration, what existing mesh components, i.e. Nginx sidecars or Vault SSL cert management, do you anticipate being able to replace or remove entirely?
Yeah, so that's an interesting question. So if you ask me if I have a one-line answer there, I do not have. But this is the thought process that I have there. So based on the details on how we enable Consul Connect, I'm expecting definitely the sidecar might get replaced with a supported or more convenient sidecar that is recommended for Consul Connect. And Vault will remain as the SSL service provider there.
Great. And then if anyone else has any other questions, let's see here. Are there any plans to look at Nomad Federation to help manage these workloads more globally?
Okay, so where did you see that question? I didn't see that. Okay.
I had a private message. I'll add it in our chat. There we go.
So what was the question? Let me just look at that. part.
Yeah.
Nomad Federation. Okay. So we have not actively looked at it at this point in time in terms of doing it. We are still trying to understand whether that makes sense in our particular way that we use our deployments, considering that Ariba's business needs requires us to have isolated deployments across regions with no cross-region communication. So we have to see where we leverage that part.
We have 2 more questions. The first one being, are you planning to implement the tracing using Nginx, or are you planning to move to Envoy?
Christian, I think as I mentioned in this previous answers, we are leaning more towards Envoy.
Okay, another question. Working with Nomad, does your org rely on any auto scaling to work with on-demand inventory? If so, how?
Okay, that's a very good question. So if you see if you remember the initial slides where I mentioned about the regions, as of today, if you see Ariba runs a lot of its workloads on bare metal data centers. So 6 regions are still in bare metal and 2 are in public cloud. So definitely auto scaling and changing the service scaling as well as the cluster scaling is an applicable thing in public cloud, while in bare metal, it is not something that you can really do. So all our design and patterns have been primarily tuned for the bare metal use cases. But as our percentage of public cloud usage shifts to the larger side, we will also be looking at both cluster scaling as well as application scaling in order to utilize more efficiently the public cloud computing resources.
Wonderful. That's we're still taking more questions. So if anyone has any, please make sure to type them in the Q&A. That's a lot of questions. That was great. Oh, we already answered this one. Are you handling console intentions? Yeah. Okay, Ranjit or Ariel, do you guys have any last words of wisdom before we hop off the webinar?
Yeah, so if anyone has any questions, you guys can still reach out to us, and it will be good to share some thoughts if on any of these topics that we discussed.
Yeah, and I'll come over the top of that. I just want to restate the co-sponsor Digital on Us. If you're looking for a third-party lens or a wider lens outside of, because as Ranjit showed, we're part of the stack and part of the workflows and part of the solution, but we're only part of it. And so if you'd like to have a wider lens on how to solve some of these problems, I can help you get in touch with the Digital on Us team.
Thanks, Josh. And I'll make sure to include your information, and then of course, Digital on Us, their information as well in the follow-up email. So everyone has that. And then again, you'll get a recording of today's webinar. And if there are any other questions, please don't hesitate to reach out. We want to thank Digital on Us, specifically Ariel and Donna, for your partnership today, and then Ranjit for being the star of our show. So thank you. We have one more question actually. Will we receive the slides as well? We haven't discussed that yet. So we will discuss that, and then it's okay to say no. Thank you, Edward. I actually don't know. We'll figure it out, and I'll send you an email tomorrow so we can figure that out. But thank you everyone so much. Have a wonderful rest of your day, and hopefully we'll see you at the next HashiCorp event.
Thank you.